So we are on lesson 50. Number 50. Finishing up with trigonometry, finishing up with 3D, solving triangles, simple cos rule, area rule. You haven't seen the area rule in a while, because you do area rule when I asked you earlier, which is two sides and included angle. Right, so when we get to BC, this side, we've got to go and establish BC in terms of trig function of y. That's the question. Now look at the sketch first. Now please read next to the sketch what all the information is, because they did tell me that OB was a flagpole or some sort of a vertical plane, and C and D and B were all on the same horizontal plane. So that means this is the ground and that thing's standing up there. So is this 360? No. Okay, but that's 90 and that's 90. Do you see how we draw it?
Yes, ma'am.
So that is parallel to this side and that is parallel to that side, because that is definitely, not when I measure this, what would be a 90. But the representation shows me that this is a 90-degree angle. They told me that this is 5 meters, I don't know. And then they gave me angles, 150 minus y, and 2y, and 1y. Right, and I've got to go and get BC. BC, I will definitely have to work in which triangle?
OCB.
In OCB, because that's the only one that has a side. There's no side here. I'm going to get to that just now to prove CD, but I'm going to do that by using this connecting side. This time they led me. They scaffolded the question by leading me where I need to go. First thing that I taught you, please go and get every single angle that you possibly can, whether it's going to work for you later, you're going to use it all or not. So this will be equal to
90 minus y.
So I've got all the angles.
No.
Can I get all the angles at the bottom?
Yes.
And what will this one be?
30 minus y.
How did you get that?
Inside and outside the
Because you've got to
triangle.
go add that up, then you're going to get 150 plus y. And then when you subtract that from 180, you're going to get 30 minus y. So that when I add them now, it's going to be 180 minus 2y plus 2y is nothing. So the sum of those angles is 180. You see it?
Yes,
So you
ma'am.
go and actually do the sum. I've done the sum and you don't use it. So, but it's fine. You've got everything that you want if you need it. So to find them for BC in triangle OCB, or however I'd like to call it, can I use grade 10 stuff?
Yes.
Because it's a 90-degree triangle, I can use the grade 10 stuff. So I could say, with my angle Y that was originally given, with this side, which is the what side? Hypotenuse, and this side I'm looking for is the opposite. I could say it's the sin of Y. The sin of Y is opposite, which is BC, over hypotenuse, which is 5, and that's grade 10. If I do want to then write down BC, it will be 5 times sin y. And the question was, write BC in terms of a trigonometric function of y. It is a trigonometric function of y. Okay. The other way was to use grade 11, the sin rule. So BC over sin y. Agreed?
Yes.
And the side I have, 5 over the sin of its opposite angle. So 90, and now we know sin 90 is 1, so I'm back to this one. To get to BC alone, we're going to have 5 times sin y
5 sin.
over sin 90, which is
1.
1, so we don't have to write it. And we're done. How many marks? 2. Once I have it, now I'm going for CD, and they've given me something terrible to prove there, and we've got to get there ourselves. So, finding CD, not looking at the answer yet, because I don't know how I'm going to get there now, but it should be with CD over sin, and this side that I've just found over sin of 2y. I'm going to use the sin rule again. Like may I said to you, sin rule you should actually always write A over sin A, B over sin B, whether you have an ABC or a BCO or a what triangle, write it down, but you don't have to write it down twice. You don't even have to write it down. It's just good practice. So when I want to write CD, it'll be CD over sin 150 minus y. And then the other side would be BC, this one that I just had here, which I'm going to substitute just now, over
Sin 2y.
sin 2y. Sin 2y. Double angle. I don't know, I'm going to use a double angle because there's no sin double angle here, so it should have disappeared. So I'm going to use a double angle there. And this
Compound.
is a compound angle. So this is why I couldn't ask you this in grade 11, because you're working with compound angles and double angles now. But the rest of it, knowing that you've got to have pairs for sin, or then on those pairs, you've got to use the cos rule with either 2 sides in the included angle or 3 sides. So it stays the same basics. Now let's apply our new knowledge. So to find CD then, we're going to have BC, which was 5 sin y, over sin double angle. I'm quite sure I'm going to have 2 sin y, cos y. Happy with that?
Yes, ma'am.
And then this is going to come to the top as well, which is going to be sin. Now, if you wanted to already expand on that compound angle, now it's fine. I'm just not trying to make it not so busy at one stage. So it'll be 1 mark for using the sin rule. There will be a mark for your double angle. The next mark is going to be for your compound angle, and hopefully somehow, somewhere, I'm going to get to that answer there, because that's my aim. That's my script note for my memo. So it'll be 5 over 2. I'm looking for.
5 over 4.
So I don't know what's going to happen, but something's going to happen. Okay? So we've got 5 over 2. The sin y and the cos y, I'm not sure yet what's going to happen. Oh no, couldn't I have already done this? So let's do. So we write a little less. So what's left? Just the cos y. But then that sin is going to be sin 150
Cos y.
cos y
Minus
minus,
sin y.
right? Sin cos sin, and sin was negative and it stays negative. How's that helping me? 150. I've got no 150 over there. You have to do the reduction formulas. You've got to go with sin 50 and make it sin 30. Can you not just put it in the calculator and give me a half? You have to. All of these sums, no calculator. So you have to first show me that sin 50, 150 is? It's not a half, it's first sin 30. Because you're doing the reduction formula, you're going to lose marks if you take it to a half immediately. Everybody knows you work with the calculator. So sin 30 because of 180 minus 30. Cos y stays cos y. This will become cos 30, but negative, together with this negative, will become a. Is that okay if I would do that?
Yes.
You'll get your marks for that. But if there's a lot of reductions, rather show each and every one on its own and then simplify. But this was only the one because that sin y at the back is going to do nothing. So it's fine if you did that. So it's a mark for the reduction formulas. Most probably just 1 mark, maybe 2. Then what? Where does that root 3 come from? Should remind you of?
Special angles.
Special angles. Right, 30 degrees, special angles. Well, sin 30, you already told me that it was a half. And cos y. And then cos 30?
Root 3 over 2.
Ah, you see the root 3 coming somewhere. And then the sin. Over still cos. And somewhere, somehow, this has to develop into a tan. So now, guys, the rest of the sum will be with 1 mark. How are you going to manipulate this to get to where you want to be? I have 5 and 2. I need 5 and 4. I have a 1 plus a root 3. So where's that 2 gone to?
Manifest on both sides.
You cannot just time the whole thing by 2. Because it's not an equation. What can you do? Carry out common 2. Where's the 2? At the bottom. I'm going to do what she says. Take out a common 2. But at the bottom, what's left? See if you agree with me? I took out a common half actually. 1 over 2. That's why it's there at the bottom. So you're actually taking out a half. And the half together with the 5 in the front will be 5 over 2. Take out the half, take out the half. Happy with that? That cause is still there, bugging me. But can you do stuff like what I'm going to do in the next step now? Can I make this whole thing 1 times and divide? You've been taught by me that you can manipulate as you like. I want them to stand together and I want this to be together because what is 5 over 2 divided by 2? 5 over 4. It will be 5 over 4. Okay? So this answer will be 5 over 4. Does it make sense to you? How can I just put stuff together because you're allowed? If it's times, divide, and you want to put this times and this divide together on one side, are you allowed to do that?
Yes.
Because I'm manipulating it to get to where they wanted me to be. So I've got 5 over 2 times actually with 1 over 2 if I divide by 2. And then on that side, why do I want to write it separately? How's that going to help me to get to 1? Because they're going to cancel it out, but I can't just throw the cos away. Basically what's happening is you've got each one over their own denominator. Cos y over cos y, and the root 3 sin y over its own cos y. You really don't need to write that step there, but just to show you. So, because I can't just cancel out over a plus and a minus, and I can't factorize. So this is another technique by saying, let's put them each on their own denominator, meaning this will become 1. And this will become 10 y. My goodness, and what, like I said, if you got here, how many marks further? Most probably just 1. For manipulating to get it to where you wanted it to be. So all is not lost. Okay, these sums are about 7 marks. So if you got 5 out of 7 and fell off the wagon somewhere along the line, it's okay. You got 5 out of 7, you got 60 or whatever percent. Question number 6, the last one, then said again that this is a vertical pole or something. Vertical because it's 90 degrees on top of the ground. And this is all on the ground. So it's a triangle here at the bottom with the pole sticking out here. So that's 90. So is this 150?
No.
Why not? Because the one is standing up and the one's here. So it's not, you can't add them together because they're not in the same plane. This is vertically and this is at the bottom, so you can't add them. That's very important that you realize that in 3-dimensional sketches. Then they also gave me 10 meters. Okay, they did give me the 60, the 120 minus theta, the theta. They were asking me first of all to find BC in terms of. Now if you're looking at the sketch, I already did a little bit for you. If this is 90 and this is theta, first find all the angles, so that would be 90 minus theta. Did I use it or not? That's 90 minus theta. I'm working with that triangle there. I'm also working, could I work with this triangle here, the skew one, like that? Have I got anything with the skew one like here? You don't have any degrees there sticking out like this side. You've only got this flat
Surface.
plane on the surface, on the bottom, in which I have 2 angles, so I can work out the Third one, I've already worked it out for you. How did I find that?
Interior angle.
Interior angle is 180. If you add that together, you get 180 minus theta. Plus another theta gives you 180. So when you're done, all of them should add up to 180. So you have to go work out the theta. Maybe we don't even use it. Who knows? Theta, and that'll be 90 minus in that triangle. So I'm just establishing again. I can't work with ACD because that's different planes. Are you with me, everybody? Okay, so that vertical ABC standing here with a flagpole there, I've got all three the angles, but I don't have any side. So can I find BC in that triangle? You need at least one side. The only side I have is the 10 meters, so I'll have to start working in triangle CBD. BCD, or however you like. So in that triangle BCD here at the bottom, we are going to definitely have to use the grade 11 because it's not a 90-degree triangle. So to find the BC, we're going to have BC over
Sin theta.
sin theta, so we did need it. We did need to go find that with the sum of the angles of a triangle. The side that you do have is 10. The partner is 120 minus theta. Question was, find BC in terms of sin theta and cos theta. I'm finding BC here, but I'm lost for a cos.
Co-function.
You with me here? Maybe co-function, but look carefully. Yes, compound angle. So BC will be equal to, let's first of all say 10 sin theta. Do you agree? Timing it to that side. But then at the bottom, compound angle, just like the previous one. Focusing on getting double angles and compound angles into the grade 11 work that you've already done. So it'll be, let's take it immediately, sin 120 cos theta, so now the cos theta is coming out, minus the cos 120 sin theta, okay? And actually, you would have been right to say sin 120 minus theta at the bottom, because it's right, but it's not in the correct form, because they asked you to write it in cos. And you're going to use that cos to get to what they actually asked you in the next question. So let's simplify. How do we simplify this?
Take out
120?
this one.
Reduction formula, and you're going to get to 60 degrees, which is special angles. The natural order of things is when you've got an angle larger than 90, make it acute by doing a reduction formula. The rest falls into place. So we've got 180 minus 60 becoming sin 60. Okay, so let me carry on here. BC is then 10 sin theta, 10, 20. But remember, I'm busy with BC and I'm trying to prove AB just now. You can't look at the stuff and say, oh yes, I see where we're going. When they start falling into place, we're very surprised and happy about it. So 10 sin theta at the top, but the bottom will then be sin 60, which is positive because it's second quadrant, cos theta. And then we got minus cos 30, no sorry, also 60, cos 60, but second quadrant cos is negative. So if we just write, is that fine?
Yes.
Okay, because nothing else changed. That was the only thing that changed. So you get maybe 1, maybe 2 marks for those 2 reduction formulas. And then what are we going to do? Special angles? Please give me a sin 60.
Root 3 over 2.
Root 3 over 2. Cos theta. And cos 60
A half.
is a half. Sin theta. And I don't have space here, so I'm going to just move this down a little bit to see. I'm trying to prove that this is the case. Otherwise, why wouldn't I just stop where I am? What was the question again? Write it in terms of sin and cos. Well, even that was sin and cos. But somewhere, to get to what they're asking me, you're going to have to go for the special angles, and you're going to have to simplify as far as you can. So whether you didn't do it there, you're going to have to do it later. So I would prefer that you do it earlier rather than later to prove by 6.2. That's what you have to prove. So how can I simplify that? Can I not again do what we did in the previous sum? If you don't see it now, it's fine, you're going to do it later. But can I not again take out a common half there? Common half. Is it a half? So that what's left is 10 sin theta. Taking out a common half, what's left? Root 3 cos plus 1 sin, which is making me a little bit excited. Okay, what will this then become? 10 divided by half? 10 divided by half?
Oh, guys.
20. There's 20 halves in 10. Making me also excited, but something else is plotting here. But I'm getting there. If you didn't do all of that now, you're going to have to do it later to get it into where you want it to be. So I had to use a sin rule, I had to use a compound angles, I had to use special angles. Maybe you didn't go quite as far as I did here, then that's okay. But we've got to go and substitute in to go to AB. Now for AB, we're going to go AB over, and that's now obviously in the bottom triangle. In the top triangle for AB. AB will be over sin 90. Oh, couldn't I have then done grade 10? Yes, you could. So AB over sin 90. And then the side I've just found, which was BC. I'm just going to mark it there with a tick so I know I've got it, because I'm not going to try and write that there. I've got the BC, and I'm going to substitute that BC just now with this thing, the BC. Okay, over, and BC's partner is the 90 minus theta in that triangle there. So 90 minus, or 90 minus is a co-function, poof puff. 90, so 90 is 1. So it's going to be AB over 1. If you want to write it, it's fine. The BC part is going to be that whole thing there, which I have developed into, or I haven't written it. Did you see it? It will be 20 sin over that bracket there. So this will be 20 sin theta over that bracket. Okay, just 20, and then the rest of it is there. But then I've still got this PC here, which is going to be a co-function. Just tell me, what am I doing if I say this? Am I right to say this?
Yes. No. Oh, yes.
Just tell me what I'm showing you. Instead of saying BC, divide by, I'm saying times by, 1 over. Technique, just to make it a little bit, not so much on top of each other. Which becomes 1 over cos theta, which I want. But where's the tan coming from? So we've got 20 sin theta over all of that at the bottom. Really doesn't tan. Can I just put them together? That's what this whole taking it apart and putting it back together is. So that is going to give me tan, because everything's timed and divided. So that's tan, which can stand there at the top, and then it'll look the way that I want it to be. What I had to go and prove. So the answer then will be 20 tan over so that I've proven what they wanted me to prove. Done.